For decades, Pluto was considered the ninth planet in the solar system, holding a prominent place in school textbooks, animations, and astronomical models. Its presence was certain, almost mythical, like a solitary guardian at the edge of our system. However, everything changed in 2006 when the scientific community decided to revise the criteria that define a planet. As a result, Pluto was reclassified as a dwarf planet, a decision that sparked controversy and disappointment among many astronomy enthusiasts. Even with this new classification, fascination with Pluto only grew. After all, we're talking about a unique celestial body with geological and atmospheric features that make it a true gem in the Kuiper Belt, a vast region beyond Neptune's orbit filled with frozen objects. The name Pluto itself comes from Roman mythology. He was the god of the underworld, a dark, distant, and mysterious figure, just like the planet that bears his name. Humanity's journey to understand Pluto officially began on February 18, 1930. On that day, astronomers at the Lines Observatory in Arizona confirmed the existence of the new celestial body after years of suspicion and photographic comparisons of the night sky. The name suggestion came from an 11-year-old British girl named Venetia Burney, who proposed Pluto because she felt the mythological deity represented well the cold and darkness of that distant world. Scientists were so impressed with the suggestion that they adopted it immediately. With a diameter of just 2,374 kilometers, Pluto is even smaller than our Moon, which measures about 3,474 kilometers. Even so, it occupies an extremely important region of the solar system. Its orbit stretches about 6 billion kilometers from the Sun, directly influencing its climate and orbital behavior. To complete a full orbit around the Sun, Pluto takes no less than 248 Earth years. And a single day there, that is a full rotation on its own axis, lasts about 153 hours. Because it is so far away, the sunlight that reaches Pluto extremely weak. If we were standing on its surface, the Sun would appear just like any other star in the sky, nothing like the bright disk we know on Earth. This immense distance means that surface temperatures rarely exceed minus 218 degrees Celsius, making it one of the coldest places in the solar system. And despite all the observational challenges, Pluto remains the brightest known object in the Kuiper Belt. For a long time, scientists believed it was actually a moon of Neptune that escaped its orbit. Today, however, we know that Pluto and the Kuiper Belt itself originated from the remnants of the formation of the outer planets in the solar system, a sort of cosmic debris that never coalesced into a larger planet. Even with powerful telescopes, seeing Pluto clearly has always been a challenge. It's invisible to the naked eye, and observing it relies entirely on advanced equipment. That's why the arrival of NASA's New Horizons probe in 2015 was a milestone in space exploration. It was the first mission to reach Pluto's neighborhood and show us real detailed images of its surface, revealing a world far more complex than anyone had imagined. The mission that revolutionized our understanding of Pluto was led by NASA's New Horizons spacecraft. This probe is part of the ambitious New Frontiers program created to explore the solar system using unmanned spacecraft. And among all possible destinations, New Horizons was chosen for one of the boldest missions ever to visit the small and mysterious world beyond Neptune. The journey began on January 19, 2006, when New Horizons was launched from Earth. Interestingly, at the time, Pluto was still considered a full-fledged planet. Only months later, in August of that same year, the reclassification to dwarf planet was officially adopted. That means the probe set off toward a planet and arrived at a dwarf planet. New Horizons had a broad and demanding mission. The probe was tasked with studying Pluto's geology, analyzing its atmosphere, investigating its moons, and above all, delivering real, never-before-seen images. And that's exactly what it did. On July 14, 2015, after almost 10 years of travel, New Horizons pass just 12,500 kilometers above Pluto's surface, an incredibly small distance in astronomical terms. Less than a year earlier, on April 15, 2015, NASA had already released the first detailed image of Pluto and its largest moon, Charon. But what came after was even more impressive. During its flyby, the probe captured hundreds of high-resolution images that revealed the surface of the dwarf planet in unprecedented detail. Textures, colors, terrain, and shadows began to tell a much richer story than anyone expected. Thanks to these images, scientists were able to map Pluto and its moon Charon in great detail, analyzing their geological and climatic features. One of the most iconic discoveries was a heart-shaped region visible on Pluto's surface. This symbolic formation is actually a massive glacier made of frozen nitrogen, which instantly became the symbol of the dwarf planet. This glacier, known as Sputnik Planitia, is so massive that according to scientists, it gradually altered Pluto's rotational axis over time. And that's not all. It also interacts with the gravity of Charon, the largest of Pluto's 5 known moons. This interaction causes a slight wobble in the dwarf planet, similar to a cosmic dance between two partners. But perhaps the most curious thing is that Pluto has a temporary atmosphere. It only exists when Pluto approaches the Sun on its long orbital journey. During this period, some of the ice covering its surface begins to sublimate, that is, it turns directly from solid to gas, creating a thin atmosphere composed mainly of nitrogen. However, as Pluto moves away from the Sun again, this atmosphere freezes and disappears. The presence of this intermittent atmosphere, one of Pluto's most exotic features, making it an exception among the celestial bodies we know, and all of. This was only discovered thanks to the New Horizons mission, which continues to provide valuable data even years after its encounter with the dwarf planet. With the images and data sent by New Horizons, Pluto's surface revealed itself to be far more complex than previously imagined. Before, Pluto was thought to be nothing more than a rocky, icy block drifting through the solar system. But the evidence pointed to a dynamic world with stunning geological formations and even volcanic activity, although very different from what we see on Earth. One of the most striking aspects of Pluto's landscape is its massive mountain ranges, some reaching up to 3.5 kilometers in height. For comparison, they are about as tall as the Rocky Mountains in North America. But what makes them truly fascinating is their composition. Instead of solid rock like on Earth, these mountains are made of frozen water, ice, which at such low temperatures behaves like stone. Besides the mountains, Pluto's surface is also marked by craters, deep valleys, and vast plains. One of the most surprising signs was the evidence of volcanoes that don't erupt molten lava, but rather a mixture of water, ice, ammonia, and methane in liquid form, which quickly freezes upon reaching the surface. These ice volcanoes indicate that there is or once was internal activity, possibly heated by radioactive processes in Pluto's core. And what lies beneath that frozen surface? Some models suggest the possibility of a subsurface ocean of liquid water protected by a layer of ice around for kilometers thick. If confirmed, this would place Pluto among the bodies in the solar system with astrobiological potential, that is, with conditions that could theoretically support microbial life. This hypothesis is taken seriously by scientists, as we know that hidden oceans also exist on moons like Europa and Enceladus, satellites of Jupiter and Saturn, respectively. But Pluto is not alone. It has at least 5 known moons: Charon, Nix, Hydra, Kerberos, and Styx. Among them, Charon stands out for its unique relationship with Pluto. It is so large compared to the dwarf planet that technically to form a binary system. In other words, they orbit a common point that lies outside both bodies. Charon has also shown signs of cryovolcanism and geological faults that point to ancient expansion processes, as if its interior had once been heated and later cooled, leaving marks. on its surface. The other moons, although smaller, also surprise scientists. Nix and Hydra, for example, reflect a lot of light, suggesting their surfaces are made of extremely pure water, ice, something unusual for celestial bodies so far from the Sun and exposed to billions of years of cosmic radiation. All this data has turned Pluto and its moon system into a true cosmic laboratory, a place where geology, atmosphere, and gravity interact in a unique way, raising new questions about how planets and moons form and evolve in the outermost regions of the solar system. And even after completing its flyby of Pluto, the New Horizons probe hasn't stopped. It continues its journey through the depths of the Kuiper Belt, sending back valuable information about even more distant and unknown objects. Its mission now is to explore regions that no human-made object has ever reached a true odyssey into. The unknown. The journey of New Horizons didn't just change what we knew about Pluto. It also transformed the way we see the outer reaches of the solar system by capturing high-resolution images, analyzing the geology, the atmosphere, and even the gravitational effects of Pluto and its moons. This mission rewrote entire chapters of modern astronomy. Before it, Pluto was a distant, barely understood shadow. After it, it became a fascinating world full of contrasts, mysteries, and possibilities. One of the most poetic aspects of this entire mission is that even after leaving Pluto behind, the probe remains active, traveling at incredible speeds toward interstellar space, like TH. The journey of New Horizons didn't just change what we knew about Pluto. It also transformed the way we see the outer reaches of the solar system by capturing high-resolution images, analyzing the geology, the atmosphere, and even the gravitational effects of Pluto and its moons. This mission rewrote entire chapters of modern astronomy. Before it, Pluto was a distant, barely understood shadow. After it, it became a fascinating world full of contrasts, mysteries, and possibilities. One of the most poetic aspects of this entire mission is that even after leaving Pluto behind, the probe remains active, traveling at incredible speeds toward interstellar space. Like the famous Voyager probes, New Horizons continues its lonely path, venturing into regions of the solar system never before explored. It has already studied another Kuiper Belt object known as Arrokoth, a lobed body that looks like a cosmic peanut. And it may in the future encounter other equally intriguing targets. And to think that all of this began with a bold idea to send a probe to a planet that takes nearly 2.5 centuries to complete a single orbit around the Sun. It's the kind of endeavor that demands not just technology, but also patience, foresight, and a passion for discovery. New Horizons represents the human spirit of exploration in its purest form, pushing beyond what's within reach, even when there's almost no practical return. Over the course of its mission, the probe didn't just fulfill its scientific objectives. It also inspired a new generation of scientists, engineers, astronomers, and dreamers. It reminded us that the universe still holds incredible mysteries waiting to be revealed, even in small, cold worlds forgotten on the edge of the solar system. And Pluto, even without its status as a planet, remains one of the most charismatic and talked about celestial bodies in our cosmic neighborhood. Its rugged beauty, nitrogen glaciers, icy mountains, intermittent atmosphere, and possible underground ocean have made it a symbol of the complexity that can exist in even the most unlikely places. If we look up at the night sky, Pluto will be there, invisible to the naked eye, but alive in our imagination, a reminder that the universe is far too vast to be limited by our definitions, and that the more we learn, the more we realize how much there still is to discover. And so, the New Horizons mission didn't just mark a visit to a dwarf planet. It launched a new phase in the exploration of the outer solar system. Every byte of data sent by the probe helps unveil the secrets of a realm still barely known. And who knows what more it might reveal in the years to come as it ventures further into unexplored space, carrying with it the legacy of human knowledge, If you enjoyed this journey through Pluto, leave a like and subscribe to the channel so you don't miss the next destinations across the universe. Share it with your friends who, like us, are passionate about space. Thanks for watching and see you in the next video. Ask ChatGPT.